All right, AP Statistics, welcome. Make sure you have your book today. Well, I guess it's too late already for that. But there will be some homework time at the end, so just ask, see if you can go get your book because we do have homework. We're going to pick up and finish 5-2 today on our probability. And let's just kick right into it. Let's see, I think it was Friday. We ended here under the distance learning, and I think we finished figuring out the probability here. Now we're going to be moving into a two-way table. Two-way tables are one of my favorites for doing probability, and I'm going to unveil an awesome project that I have been working on for many hours tomorrow that is just all two-way tables, but you're going to love it, I know it. This is the best way, I think, to do probability. And so here's the situation. So a college class came together and they said, hey, I wonder what the probability of having pure steers are. Um, let's see if there's, between males and females. So they have the males over here. So there's a total of 90 males, total of 88 females. And out of everybody, they did 178 total. Then they gathered whether they had pierced ears or not. All right. So here's the first thing. What is the probability that somebody has pierced ears? Okay, what is the probability that somebody has pierced ears? Well, what I'm going to do is I'm going to come down to the pierced ears section and say, ooh, this right here is yes, they have pierced ears. Now, I don't care if it's male or female, I just want to know if they have pierced ears. So it's 103. 103 people have it out of 78. So the probability that they have pierced ears is 103 out of 178. So it's that pierced ears column. Hopefully you guys make that clear. And the actual decimal point for that, let me see. I can't write right now on this screen, but it is 103 divided by 178. 103 divided by 178. And I got a decimal of 0.579 roughly. So I would also write that as a probability. Don't just leave it as a fraction. All right, next. What is the probability they are male with no pierced ears? So they are male and they have pierced ears. Okay. Now this is one of those. You remember how I said and looks like an upside down U? All right. Um, so I need to look at the male categories, and they have pierced ears. Well, how many males are there that have pierced ears? 19. Would you agree with that? It's kind of where the males and the pierced ears, where do they come in contact with each other? So it's going to be 19 out of 178. Let's see. So when we say and statements, they both have to have that in common. All right? It's what they have in common. Now, to kind of give you an illustration here of that, I'm going to pull up this. And let's say this right here, and I can write on this as much as I want. So this is the probability of being male. Okay? So let's say male. All right? Ah, that's horrible. Ugh. How horrible can I get? Let's see. It's not going to let me do anything. Anyway, so let's say this is the probability of it being a male. And this is the probability of having pierced ears. Now, these are going to overlap. They are not disjoint because males can have pierced ears. And this right here, there's going to be an overlappage. That overlappage, are they going to let me write? Hold on. I'm going to make it right. All right, here, I'm going to shut this down. There we go. Okay. Now they'll let me. Um, uh, so these are males and ears pierced. All right, there's a little overlappage here. Oh my goodness. Can it get any worse? Alright, there's a little overlappage right about there and there. Okay, that overlappage has males and they have ears. So back in the context of where we were at, um, this is the males, and this is the ears. Where's the overlappage? At 19. Okay, that was a long story, but I think I got it. Next, lastly, is male or has pierced ears. Now, here's the real kicker. I'm going to exit out of this again. Now, they're males or have ears. That means they could be males or they have their ears pierced. So we're talking about anybody who has their ear pierced or are males. All right. Now, a lot of times people like to say, so that's just to give you an illustration of what we're doing here. It's all of this. Okay, it's all of it. All right. We'll clean it up just so I don't look like I'm a kindergartner. All right, and all of that. That's I'm looking for the probability now. Well, a lot of people like to say, okay, so I'm going to take them and I'm going to say, all right, if they have ears pierced is 103, and they want to add 90 to that, so that would be 193 out of 178. That doesn't make sense, though. If I take 103, the probability of having them pierced, and the probability of males is 90, that's 193. Remember, I can't have anything more than 178. So what's going on? How come I can't add these two totals together? It's because of this little guy right here. All right? And he's overlapped twice. It's kind of like, I'm going to bring this guy back. It's this area right here. Okay? This area right in here is overlapped twice. So to get the true probability of both, we actually need to remove this and statement here one time. We'll cut that off. We'll just take our scissors and just snip it. Just snip, 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 and cut it off. All right? So, and statements, we need to remove that, or statements, we need to remove that middle one, middle ground. So here we go. What do I like to do? Instead of taking these two, 103 and 90, and then subtracting 19, I like to just say, all right, just add up these three digits right here. If you add up these three digits, you'll get your total. So, what is 19, 71, and 84? Okay, 1971 and 84, 1971 and 84. It's going to total 174 out of 178. So, almost everybody is male or has their ear pierced. Okay, very few people are not male or have their ear pierced. So that means there's only 4 girls who don't have their ear pierced. Okay, that's how we would do the probability on those. All right, moving on. Like I said, here's the Venn diagram and how it shows. And obviously, they are not mutually exclusive. They do share stuff in common. So the probability of A and probability B is in the middle. Event A is 90 over that. Event A and B, and then so on and so forth. Okay. And here's the general rule, addition rule for two events. If A and B are any two events resulting from some chance process, then A or B, now remember this is the OR statements, okay, OR statements, you take your A, you add your B, and then you minus A and B. Now that's very confusing, I think. I don't like this formula. I would much rather just say, hey, listen, let's make a two-way table and say, let's add those three numbers together, and boom, bada bing, I've got it. So all the ones in my males, all the ones in my pierced ears, and I don't have to worry about the overlappage here. Okay. Anyways, there it is. Can I move on? Good. Next. Complementary. Complementary, and I think I already mentioned this already, but if there's a C It is the exact opposite. All right. So complementary contains exactly the outcomes that are not A. So if I wanted to find out A, I could find out A, but then not A, I would subtract 1, or 1 minus A. If events A and B are mutually exclusive, okay, meaning they don't touch, there's nothing in common. So, there's nothing in common between um, whatever. I gave the illustration of people wanting to date. There's nothing in common with us. We can't get together. Um, and then intersections. I already have given you illustrations here, and is going to be that little section in the middle, meaning where they both are. Okay. Or statements would be everything. Okay, A and B. Or say A or B, I should say. A or B. And remember, you've got to minus that little section in there because otherwise it's going to be overlapping. All right. Keep the symbol straight. They say U for union and this for intersection. I like to think of this as and A. And if you want to think of U as union, that's fine with me. But there you go. Okay. Let's do one more here. You ready? Recall the example on gender and Pierce mirrors. We can use a Venn diagram to display the information and determine probabilities. So we knew that 19 are in common, right? So that means if 19 are in common, that means 71 are going to be out here in this little area. And 84 are going to be out here in this area. Okay? And then what's left? This 4, which I don't know if you remember me saying, but that would be females that don't have any ears pierced. So very few females have ears pierced, apparently. All right, and we can see them all there. Male and pierced ears is going to be 19. Male and no pierced ears. So male and no pierced ears would be 71 because they're male and they don't have any ears pierced. I like to say this though, male and no pierced ears. Which is the section that has male and no pierced ears? 71, right? I think the Venn diagram makes things a little bit more confusing. What about females and pierced ears? Well, I like to come over here and I say females are right here and pierced ears. So females and pierced ears. That means 84 of them, right? And then finally, female and no pierced ears. So I go female and no pierced ears. That's 4. Female and no. All right. So in the general gist of everything, remember all of our things complementary. Always take 1 and minus the probability of it, and so on and so forth. I think that is our general gist of what we're doing here today, and I think we should do all right on our homework. So let me pull that up for you. And homework for today, very short, only 4 problems. It's because tomorrow you're going to get the big book probability. Homework is 43, 45, 49, and 53. If it needs to be paused, please pause the video. Guys, enjoy your Monday, all right? I am sweating it out up at the Dells. I'm sure it's just long and boring and just not exciting at all. I will see you on Thursday, but you have one more video of me tomorrow. Thanks, bye.